In part A, they ask us to revisit Unit 1, dynamics, to figure out the final velocity of this object. So it has a starting velocity of 10 meters per second east, and at a time of 6 seconds where you have a net force of negative 5 newtons east. So I changed the west force to negative east because I want all my directions to match, and a mass of 2.0 kilograms. We have to find out the final velocity v2 is a question mark. So with net force and mass, I'm confident I can find the acceleration. So I'm going to basically assume that I know the acceleration and choose my uniform acceleration equation, which would be number 1, posted in our classroom. Acceleration will be v2 minus v1 over delta t. Rearrange it for v2. So that begins by multiplying both sides by delta t, and then adding v1 to both sides. As for the acceleration, it's going to be net force divided by mass according to Newton's laws. I'm putting the v2 on the left side, just as my preference. So acceleration will be the net force over the mass. That'll be multiplied by the time added to v1. And I'm ready to substitute values. So negative 5 newtons over 2 kilograms times 6 seconds added to 10 meters per second east. Okay, I'll calculate all that out. It appears that it will be negative 5 meters per second east. So 5 meters per second west. That's the answer to A. And I believe what happens is we're going to try to verify that we get the same answer using impulse momentum. So let's go to part B. Determine the impulse imparted on the object by the net force using the impulse formula. The impulse formula is impulse equals force times time. They ask us to do it for the net force. So it's net force times time. That will be negative 5 newtons east multiplied by 6 seconds. That's going to end up being negative 30. It'll be in Newton seconds, interestingly, Newton seconds, which is equivalent to the standard units of momentum, kilograms meters per second. Negative 30 of those east. So that's part B. C. Determine the initial momentum of the object using the momentum formula. The initial momentum, P1, will be mass times initial velocity. That's the momentum formula, P equals mv. So that would be 2.0 kilograms times 10 meters per second east. That makes 20 kilogram meters per second east. Okay, there's part C. Part D, determine the final momentum. The final momentum, I guess here we're using the velocity from that we got from part A. Yeah, we'll use the velocity we got from part A. That's the final velocity, so that will be 2.0 kilograms times negative 5.0 meters per second east. that ends up being negative 10 kilogram meters per second east. Okay, so part E is what they want us to verify something. They want us to verify that the impulse momentum theorem is true. The impulse momentum theorem, theorem, they claim that the net impulse on an object will equal to the object's change of momentum. That's the impulse momentum theorem. We're going to test to see if that happened for this example. And to test whether or not an equation is true, the proper setup is to do a left side, right side method to calculate each side of the equation independent of each other and seeing if they're equal. So on the left side is the net impulse, which is the answer to part B. We got that it's equal to negative 30 kilogram meters per second east. The right side of the equation, delta P stands for P2 minus P1, the change in momentum. For P2, we take our answer to D. Our answer to D was negative 10 minus P1, which is our answer to C, which was 20, and we see that equals to negative 30 kilogram meters per second east. And the units of parts B, C, and D all match up to make kilogram meters per second east. So left side equals to the right side. Therefore, the impulse momentum theorem is correct for this example. All right, there we go.